Good evening, everyone. Now we're going to go through our second big idea for Chapter 3. This is all about reflections. You go to page 7, we'll be able to start working on it. So, reflections. A reflection's a pretty simple concept. It's just like a mirror image. Take a look at A, B, C, and A prime, B prime, C prime. That figure, ABC, has been reflected to get A prime, B prime, C prime. And it was reflected across a specific line. This line. Now there's some really cool properties of a reflection which allow us to make reflections even if we don't have a grid and even if we do. The first is this, okay? Notice how the closer points, their reflections are closer. So A is the closest point, it's actually on the line, so its reflection doesn't even move. Like something on a mirror, you reflect it, it doesn't get very far from the mirror. B is a little further away, so its mirror reflection is also a little further away. If you look at the distance from this, like this line M is our mirror. C is the furthest, so C prime will be the furthest. Okay, that's one cool property. Another cool property is that if you take a connecting line from B to B prime or C to C prime, the distance is going to be mirrored. Take a look at B to the slope, it'll be mirrored right here. See, it'll be mirrored. But they'll also, that connecting line, B prime, is actually going to be at a right angle with our line of reflection. Now, this line here, it's a line, we reflect across it, so we simply call that line the line of reflection. Okay? All right. A reflection reflects across a line of reflection and objects today at a certain distance. But how do we write the rule? Well, because it's a reflection, we start with the letter R. Capital R implies that it's a reflection. And then in the subscript, we write down what line we reflect across. In this case, we reflect across line M. Okay? Then we apply it to an input. In our figure, the input is triangle ABC. And that produces an output, A prime, B prime, C prime. Okay? Now, if I wanted to, I could put the triangle symbol in front. The triangle symbol is not such a big deal. If it's 3 points, you're just saying you're reflecting those 3 points. And if they're connected, writing triangle is pretty helpful, but not necessary. And that's how we write our rule. Just to make sure we understand here, this R is the word. It tells us to reflect. Okay, it's the transformation. The M tells us the line to reflect across, or the line of reflection. Okay, this ABC right here is the input. Just like a function in algebra has you take the input, x, and then apply a function to it, f, or g, or h of x, g of x, f of x. That's what we're talking about here. And then this will produce our second part, our second part, the output, which is our y-coordinate in a regular function. Here, this is our output. Okay, it's not a individual point, it's a collection of points based on an object. Okay, so it says to reflect across this line a certain input to produce an output. Now, in our class, we're going to focus on inputs that are almost always the entire figure being drawn, but you could just reflect individual points and see what happens there. All right, let's go ahead and actually apply this reflection. Take a look at this figure, FGH. We want to reflect it down here. So I want you to reflect it. An easy way to do that is to take a piece of paper that you can trace on, trace FGH and the line of reflection, and then take that paper and fold it so it makes a crease right at the line of reflection. And wherever the figure ends up, you're just going to have to go underneath the tracing paper and put it back on the original figure. Now, I can't do that because this is an iPad and you won't be able to see that very well. So, instead, what I'm going to do is I'm going to use the properties of the reflection. I know that H goes just like that. I know that G connects to the line of reflection just like that. And I know that F connects to the line of reflection just like that. So what I'm going to do to each of these is I'm going to duplicate them and move them to the other side of the line of reflection. So now I've got double that length. Remember, I said the line of reflection copies that length. Okay, so I'm just copying it all over, and this will be my reflected object. F, G, and H. I think I named that wrong as I was going. This is H, this is G, and this is F. But since they're my prime ones, I put H prime, G prime, and F prime. That's a reflection. Notice again that this length and this length are the same, and they meet at a right angle with my line of reflection. This length and this length are the same. This length and this length are the same. All right. That is my reflection. Go ahead and see if you can reflect this figure yourself. Again, just to restate that, trace it, make a crease, and flip it over that paper. All right, and then trace it back onto it. Okay, so how can we do this to a much bigger figure? Well, let's take a look at this on a grid. This is F, G, H, and J. So we're going to go ahead and plot those points. We're going to start with F. F is 0, 3. G is 2, 4. H is 4, 2. And J is -2, 0. So I've got those several points. Now I'm going to connect them. And I'm going to connect them with purple. That probably won't work. Nope. So I'm just going to connect them with individual lines here. Boom, 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 and boom. Okay, that's my figure. I'm going to label it F, G, H, and J. All right, so now we've got our figure. Let's go ahead and complete the first reflection. This one doesn't give us a specific name for the line. It says reflect across the x-axis. The x-axis is this line. Notice how it doesn't say reflect across x. X can be any number you want, but the x-axis is a specific place. So if I'm going to reflect it, I just know that those lengths need to be preserved. So the distance from the line of reflection to J, let me label the line of reflection, that's X right here. The distance from my line of reflection to J is 0. So J prime is going to end up right there as well. F is 3 above the line of reflection, so it's going to go 3 below. And I know that this line of reflection is horizontal, so my vertical lines are perpendicular. G is 4 away, so it's 4 below. H is 2 away, so it's 2 below. Okay? And now I've got my new figure. J is there, F is here, G is here, H is here. And I can go ahead and draw those and connect to them. Hey, it worked this time. Yay! All right. But, of course, I want to label them properly. This is also J prime. This is F prime, G prime, and H prime. Awesome. So I was able to reflect it across. Now, one thing I want you to notice are the coordinates here. Take a look at the coordinates of the original. 0, 3, 2, 4, 4, 2, and -2, 0. Now, when we reflect it, what are the coordinates that we get? -2, 0 for J. F is 0, -3. G is 2, -4. H is 4, -2. Now, you might notice that each of the y coordinates have switched signs. So we could actually write it as a rule like this. A reflection across the x-axis of any point with our coordinates x and y is going to produce the same x, but the y coordinate's going to be the opposite. There we go. That's our general rule. All right, I want you to go ahead and try to reflect it not across the x-axis, but across the y-axis. Pause this video and see if you can do that yourself. Reflect it across the y-axis. One of the biggest things in math is trying, so make sure you try. Pause this video now. All right, hopefully you've reflected it. Let's see if yours compares to mine. It's supposed to reflect across this y-axis, so we need to know where those points will go. I'm going to pick, let's see, red, just to distinguish between them. So if I look at J, J is going to reflect across that. It's two-way, so its reflection is two-way on the other side. F reflects, but it's right on the line, so it stays there. G is over here. H is right over here. So that's our figure. Let's see if it'll work. Man, when I was doing this in class, it never worked, so I'm very glad that it is now. So this is J double prime, because we already did J prime. This is F double prime. This is G double prime, and H double prime. Now, you might have noticed something. I'm not going to write them out individually, but you could write out the coordinates. But notice how this was -2. Now it's +2 for our x coordinate. This was +2 for, still 4 on the y-axis, but now it's a -2. You might notice here the x coordinate is switching. So whenever we reflect across the y-axis, we end up with our x and y becoming the opposite of x and the same y. There we go. We did our reflection. All right. So let's see if we can apply those rules to these figures. Take a look. You got triangle ABC. What's the reflection? What's the result going to be if we reflect it across the x-axis? Well, since I know that A, B, and C, I know what their coordinates are here, I know what their reflected coordinates will be as well. I can just write those out. A is -5, 6. That's going to translate to A prime, which is, because I'm reflecting it across the x-axis, the y-coordinate will be opposite, -5, -6. B is 1, -2. So that's going to become B prime, which is 1, 2. And C is going to be -3, -4. So C prime is going to be -3, +4. There we go. Now, you can go ahead and do the same thing with the reflection across the y-axis. What happens to these coordinates? If you write them out yourself, I'm going to tell you what they are, but I won't write them down this time. You want to make sure you can write them down yourself. All right, let's talk about A. A was -5 and 6. It's going to become +5 and 6 because that x coordinate switches. B was -1, -2, so it's going to be -1, -2. C was -3, -4, so it's going to be +3, -4. Notice how that coordinate switches, but the y does not. All right. So, hopefully this is helpful to you. And the last thing that we're going to do on this video is reflect across a line and find that line of reflection. If you see this picture on your paper on page 8, go ahead and see if you can draw the line of reflection. Remember the properties of that. The connecting lines are the same length on both sides of the line of reflection. All right. This is the first time I'm ever doing this, so let's see if it works. Boom. You should have gotten a line that looks like this. Now, one thing to note is the distance from M to here and here to M are the same. K and here are the same. This is something that we've been through before. That's called the midpoint. It goes through the midpoint of that line. Okay? Now, what if we wanted to write the equation of this line? Well, we could just pick a point on it. I'm going to pick this point, and I'm going to look at the slope. So if I look at the slope here, I know that it goes over 1 and up 1. So my equation would look like this. It would be in that form. Y is equal to m times x minus h plus k. Since I picked the point 2, 2, and the slope of 1 over 1, my equation looks like this. So how would I write the rule? Well, I could write the rule like this, but it looks pretty darn complicated. Okay? But it's still the same kind of rule we've had before. Reflect. Here's the line of reflection. here's the input, and then here is the output. Okay, so we've got that same thing going on, but I can make it a lot simpler if I just label the point or the line with a name. And it looks a lot better if I write it like that. See how it says reflect the line, reflect across line T, and that's MKL to produce M prime, K prime, L prime. Awesome. All right. You've got a few extra problems you can work on here to develop your understanding of reflections, but a big deal is just to practice this, especially reflecting across an axis. You want to be able to do that for sure.